Hello everyone, today I'm going to talk about problem 11 question 2. It's given that it's suggested that the following function of v, and we are given three forms of v, fv, and it may represent an autocorrelation function of a Wilson stationary stochastic process by setting v equals to tau, or a spectral density function by setting v equals to omega, or both, which functions fv may represent either or both. So if we look into the details, we can know that suppose R tau is an autocorrelation function of a real Wilson stationary stochastic process xt. Then is even and R tau is less or equal to R0. And its Fourier transform is non-negative, so that it can be Wilson stationary stochastic process. So if the S omega is non-negative, and we can know that and is also a Wilson stationary process, so S omega can be a power spectrum. So for question 1, that we know that f v equals to e to the power of minus absolute value of v, and it can represent an autocorrelation function because e to the power of minus absolute value v is even, right? It's even, and we know that in the all value interval, the e to the power of minus absolute value v is less or equals to e to the power of 0. And in Fourier transform form, e to the power of minus absolute value v equals to 2 alpha over alpha squared plus omega squared, and is non-negative. So it could also represent a power spectrum because we know that it's non-negative, and is also a Wilson stationary, so it can be a power spectrum. For question B, fv equals to sine v squared over v squared. It can also represent an autocorrelation function because sine v squared over v squared can be, if we plug in the tau, we know it's even because it's all the denominator and denominator is all even function, and so is the entire function is even function. And we know that if we set tau equals to limit 0, we know that it equals to 0, equals to 1, and in the whole tau interval, we know that sine tau squared over tau squared are all less or equals to than 0, and we know that it's also non-negative, so it is a autocorrelation function of Wilson stationary, and also because that fw is larger than 0, is non-negative, so it can be represented as a power spectrum. For question C, we are given that fv equals to 1 if the absolute value of v is less or equals to alpha, and it equals to 0 otherwise. So we can know that based on the knowledge we learned before, that the functions for Fourier transform is to multiply sine alpha omega over omega, which is not non-negative because we know that alpha and omega can be negative, and sine alpha can be negative. So it cannot be represented as an autocorrelation function of one stationary, but it can represent a power spectra because we know that Fw is larger than 0. So it's the analysis of the 3 Fv. So this is the final video for the probability stochastic course. And thank you for watching. Thank you for your company. See you next time.